Hello everyone, today we will discuss the conservation of linear and angular momentum. First we will define the linear momentum. You know that if there is a particle of mass m and its linear velocity is u, then you know that the linear momentum of the particle is equal to mu. Now what is the meaning of conservation? Conservation means constantness. Now suppose here you have a system of two particles. The one particle has mass small m and its initial velocity is u. The other particle is having mass capital M and its initial velocity is 0, or you can say that it is in rest. Now we can find the linear momentum of this system before collision. You know that from your earlier class that the linear momentum before collision it will be equal to mu plus capital M into 0, or it is equal to mu. Now suppose there is a collision, and after collision the whole system travels with velocity say capital V. Then we can find the linear momentum after collision. Okay, so linear momentum after collision will be this will be small m plus capital M. This is the mass of the whole system, and because this whole system travels with velocity v, so this is the linear momentum after collision. So the conservation of linear momentum means that the linear momentum before collision is equal to linear momentum after collision. This is known as the conservation of linear momentum. You can understand it by taking an example. You have a system of two particles. Suppose this particle has mass say 2 kilogram and its linear velocity is suppose 15 meter per second, and the other particle it has mass 5 kilogram. Before collision, let us say its linear velocity is equal to 0. Now we can find the linear momentum before collision. It will be into 50 30 kilogram meter per second. Now suppose after a collision the velocity of the mass having 2 kilogram, its velocity becomes say 5 meter per second, and now we can find the velocity of the mass capital M by the using law of conservation of linear momentum. Now it will be suppose here the mass of the initial particle was 2 kilogram, so after collision it will remain the same, so its mass becomes 2 kilogram and its linear velocity becomes 5 meter per second. So the other particle having mass 5 kilogram, so let us say its velocity is v. Then from the principle of the conservation of linear momentum, you know this will be equal to 30, and this is the linear momentum before collision. So here you can find v, it will be equal to 4 meter per second. So here you can say that the particle having mass 2 kilogram has the linear velocity 5 meter per second, and the particle having mass 5 kilogram has the linear velocity 4 meter per second. It is to be noted that the whole system, the linear momentum of the whole system is conserved, not the individual particle, because if you see here earlier before the collision, the linear momentum of the particle was equal to 30 kilogram meter per second, but now after collision its linear momentum becomes 10 kilogram meter per second. So individually the linear momentum is not constant of the system, but as a whole system the linear momentum is conserved. This is known as the conservation of linear momentum. We will discuss the conservation of angular momentum. You know that how the angular momentum is defined. Mathematically you can write angular momentum J is equal to R cross P. Here J is the angular momentum, R is the radial vector, and P is linear momentum. Angular momentum is basically related to the rotational motions. Now suppose there is a particle of mass m and its linear momentum is say p. Now if you have to calculate the angular momentum of this particle which is having mass m about origin O, let us say the distance between the origin and the particle is, say it is r. Now if you have to calculate the angular momentum of this mass m about the origin O, then it will be equal to J is equal to R cross P, or you can write J is equal to R mod P mod sin theta unit vector n. The direction, because angular momentum is a vector quantity, so the direction of the angular momentum will be perpendicular to both of the r and p. Now say you can also write it as j is equal to, mathematically it is equal to p r perpendicular. How you can write it as? You can write it as, suppose this is the mass of the particle and its linear momentum is p. You have to calculate the angular momentum about O. So this distance is vector r. Now if you move it in downward direction, let us say it is a perpendicular distance, it is point K. Now this angle is equal to say theta. So here you can find the value of this angle is 90 degree. So here your sine theta will be equal to OK upon vector r mod. So OK is equal to r sine theta, or it is your r perpendicular is equal to r sine theta. So the angular momentum is also equal to p r perpendicular distance. The direction of the angular momentum you can find by the right hand thumb rule. If your fingers are rotating in the anti-clockwise direction, then the direction of the angular momentum will be represented by thumb. Or the other example, you can take the wheel. If a wheel is rotating in anti-clockwise direction, then the direction of the angular momentum will be in upward direction. If a wheel is rotating in clockwise direction, then the angular momentum will be in downward direction. So you know that your J was equal to R cross P. If you differentiate this with respect to time, then your dJ or dt is equal to R cross P dot plus R dot cross P. Now this becomes R cross, this is equal to force from the Newton's second law of motion, and this becomes 0 because R dot is equal to velocity and P is equal to mv. So V cross V is equal to 0. So here we can write dJ over dt is equal to R cross F, and this is, you know that it is equal to torque of the system. Now if the torque is equal to 0, then you can write dJ over dt is equal to 0, or your J is equal to constant This is known as the conservation of the angular momentum. Thank you.